Okay, good morning, guys. We are going to be learning about symmetry today. Let me get back to there we go, my first screen here, my first slide here. So we are learning about the lines of symmetry. So what we already know about shapes is how to describe two-dimensional shapes. Now, on Monday and Tuesday, we looked at shapes, we looked at their sides, and we looked at their angles. And we put them in categories based on their lines, okay? So we put them in categories. Okay, are there lines parallel? Are there lines perpendicular? Are they neither? Or are they both? Okay, so we looked at how to put them in categories by their sides or lines, and we looked at categorizing them by their angles. So we had to think, okay, are they acute? Does the shape have just acute angles? Does the shape have only obtuse angles? Does the shape have only right angles? Or does it have a mixture of a little bit of both? Or one or two or all three? So we did that on Monday and Tuesday. But today we are going to recognize lines of symmetry in two-dimensional figures. So really two-dimensional shapes, okay? So let's go ahead and get started with lines of symmetry. And I'm going to have you guys watch a video, an introduction video over that. So let me get this going. Hopefully you can see it. Okay.
To answer this, which shapes are symmetrical? To answer this, we need.
Here we go. Well, hopefully it loads. Sorry, guys.
I want to think about whether this blue line represents an axis of symmetry. And the way we can tell is if on both sides of the blue line we essentially have mirror images. So let's imagine, let's take this top part of this polygon, the part that is above this blue line here, and let's reflect it across the blue line. You could almost imagine that it's a reflection over some type of a lake or something, and see if we get exactly what we have below. Then this would be an axis of symmetry. So this point right over here, this distance to the blue line, let's go with the same amount on the other side, would get you right there. And so you immediately see we start ending up with a point that is off what's actually here in black, the actual bottom part of the polygon. So this is a pretty good clue that this is not an axis of symmetry, but let's just continue it just to go through the exercise. So at this point, if you reflected it across this blue line, would get you here. This point, do a different color. This point, if you were to reflect it across this blue line, it would get you, make sure I can do that relatively straight. I can do a straighter job than that. So if you go about that distance about it, and I want to go straight down into the blue line, and say I'm going to go the same distance on the other side, it gets me to right around there. And then this point over here, if I were to drop it straight down, then if I were to go the same distance on the other side, it gets me right around there. And then finally this point gets me right around there. So its mirror image of this top part would look something like this. Would look something like this. My best attempt to draw it would look something like this, which is very different than the part of the polygon that's actually on the other side of this blue line. So in this case, the blue line is not an axis of symmetry. So this is no, this blue line is not an axis of symmetry. Now let's.
So the teacher here is calling it an axis of symmetry, but we're going to refer to it as a line of symmetry. Okay? So when he says axis of symmetry, he is talking about the line of symmetry.
Get over here. And our eyes pick this out very naturally. Here you can see that it looks like this blue line really divides this polygon in half. It really does look like mirror images. It really does look like, if you imagine that this is some type of a lake, a still lake, so I shouldn't actually draw waves, but this is some type of a lake, that this is the reflection. And we can even go point by point here. So this point right over here is the same distance from, if we dropped a perpendicular to this point, as this one right over here. This one over here, same distance as this point right over here, and we could do that for all of the points. So in this case, the blue line does represent an axis of symmetry.
Okay, so we just watched one video, and now the upcoming video we are going to identify symmetrical figures or symmetrical
We need
shapes.
to know what it means for a shape to be symmetrical. A shape is symmetrical if it has at least one line of symmetry. A line of symmetry. And now that answer is only helpful if we know what a line of symmetry is. So let's talk about it. A line of symmetry is a line where we can fold the image and have both halves match exactly. Let's look at an example. Let's maybe draw a circle, and then we can put a line on that circle. Let's draw a line maybe somewhere like this. This line is a line of symmetry if we can take one side of the line and fold it onto the other and have them match exactly. So let's take one side, doesn't matter which one, let's say the top side. And if we were going to fold this top side down onto the bottom, would it match exactly what is shown under here? Let's see, it would probably look something like this. And does that match exactly? No, definitely not. So this is not a line of symmetry. Let's try another line. Maybe if we drew a line, and we'll try to get as close down the center as we can here, like this. Try to be as close to the center as possible. And here, if we took one side, again, it doesn't matter which side, let's say over here, let's say the left side, and we folded this left side onto the right side, would it match exactly? And if our line truly was in the center of this circle, then yes, it would, which means that this line is a line of symmetry. And because we can draw this line of symmetry on our circle, it means that our circle is symmetrical. Shapes are symmetrical if they have at least one line of symmetry. And circles have many, many, many lines of symmetry. There was many places we could have drawn a line and folded it so that it worked, so the two halves matched exactly. But here's one, and as soon as we find one, we know we have a symmetrical shape. So let's go back to the shapes we were given. We can start with the triangle. If we draw a line, maybe a vertical line, let's try to draw it as close to the middle as possible, something like this. And we fold, let's take one side, if we fold this side over, these two lines might match up nicely. But this line here is going to create something more like this, which does not match what's shown over here, so that's not a line of symmetry. And anywhere else vertical, same thing, we're not going to have it lined up. So let's try maybe a horizontal line. Is there anywhere horizontally we could draw a line? And again, I think we're going to see the same thing, that the top and the bottom of the line are not going to match up exactly. So maybe one last thing we could try is a diagonal line, something like this. Maybe this could be our line of symmetry. If we fold this bottom side, this might line up pretty nice here. And then this side is going to do something like this. So it's close, it's the closest we've gotten, but still does not match exactly. For it to be a line of symmetry, it needs to match exactly. So we weren't able to find a way to draw a vertical line or a horizontal line or even a diagonal line. So this shape has no lines of symmetry, so we can say it is not symmetrical. Moving on to the rectangle, let's try here. Again, this time maybe we'll try a horizontal line. We can draw one right here. And if that line truly is in the middle, which is what I've tried for, then this side should match up nicely to this one. Across the top should match across the bottom. And these sides, if I was right at the halfway point, should fold over each other also. So it has a line of symmetry, so it is symmetrical. It has more than one line of symmetry. It has another one in the middle right here. But once we found one, we know that it's symmetrical. And finally,
So this is something I want to focus on quickly, is that a shape can have more than one line of symmetry. So our rectangle, if you were to fold it along this middle line, would fit evenly and would reflect evenly. And if you were to fold it along this line, horizontal line, it would also fold equally. So it is important to know that a shape can have more than one line of symmetry.
let's look. We have a pentagon. Here again, trying a line in the middle in some way is usually a good place to start. We can try to draw a line right, if this is right down the center here. Then if we folded this side, should line up nicely to this side, and this side would overlap, and these two would match exactly. So again, has one line of symmetry, so it is symmetrical. And just like the rectangle, this one had quite a few lines of symmetry. Here's another line of symmetry. Here's another line of symmetry. Here's one more line of symmetry. And so it has.
So if you were to fold this pentagon on these lines, they would fold evenly. So this pentagon actually has...
It looks like 1, 2, 3, 4 lines of symmetry. But as long as it has one, it is symmetrical.
Okay, and there's actually one more line of symmetry, and it would go here from the top of this point of the pentagon to the middle of this bottom line. I'm going to add that on so you can see. So let me just annotate over the desktop real quick so you can see this. Give me just a second so I can annotate over. Where is that? Okay, so you could actually go from the top down to the bottom here. And that would be another line of symmetry. So going back to what I said earlier, a shape can have more than one line of symmetry. So we are going to count how many total lines of symmetry this pentagon has. So here's one line of symmetry. Here is 2 lines of symmetry. There is 3 lines of symmetry. Here is 4 lines of symmetry and 5 lines of symmetry. So the pentagon actually has 5 total lines of symmetry. Okay, I'm done with this video. Okay, whenever you are done watching this video, you need to watch the other video about lines of symmetry, okay? All right, guys. Go ahead and close out of this video and get started on the next one. Stop recording.